Howdy guys, welcome back to the channel and welcome back to the F15 XXL video. We are in video 6 in the series and it is organization time. We have a big mess in the front of this aircraft. Fortunately, there's lots of room. We can get almost all of it done without the nose attached, so very cool. Lots to do in this episode, so without further ado, let's dive back in. All right, last video we had completed our wings, so those are done. Our connectors were part of that as well too. Still have to add a little bit of aero epoxy on the back side of those pieces of wood, so we'll get that done next, and then we'll jump into our wiring. Now, fortunately in the last video, we needed to get our flap servos done up, so we basically made the servo leads and they're plugged into the central box right now, but those flap servo leads come right to the front of the fuselage here. So we're going to do the same thing with all of the other cables. So at this point we can basically add all of our cable ends on here. With the ends comes adding a label as well too, so you can see there we've got flap right, flap left. Basically all of our surfaces have the label. Now we've got our board ready to go. We also painted that board in the last video. So here's our main equipment board. We've got the arrow on the bottom for forward. So what needs to mount on here essentially is our UATs. Now we don't actually have those UATs yet. We're using some, I think they're called Digitex. I've got one for my Picaro that we can use as a template, but we're gonna fit our UATs here, fuel pumps here, central box, Cortex, air system, all of that stuff needs to go on this board. Now we do have the option as well too to put stuff like our lighting controller can go on the side here. So we've got some other areas where we can run stuff. The intakes are also there as well too. So lots of room in this area to put everything. All right, so doing a little bit of organizing and sorting on the main tray. So we are getting 2 of these UATs from Joe Nall. So we need to wait for these guys before we can install them in the aircraft. But fortunately I have one of these that's going in my Picaro, and this is enabling us to get the spacing and positioning and everything sorted out. So now with this in place, we know where we can lay everything else out. Our fuel pumps I think are going to be really close, like right here, and that's going to work out well because it'll be just this tiny little run to the actual fuel pump. So we'll get that stuff sorted out. But that's good. That's where our UATs are going to mount, and that is in this spot right here. So nice short run from the tank to the UAT as well. Now this setup here that I'm using, this is for my Picaro, right? This UAT is not going in this aircraft. So when we do this setup for the F15, we'll have the high flow fitting right here, this 6mm fitting right there, which will be good because the 8mm line coming from the tanks will go here. This 6mm line goes to the fuel pump. All right, so we are working on the tray organization still here, and maximizing space is important. Even though this tray has a lot of room, it's going to get eaten up very quick. So if we were to put our fuel pumps in this area, that would take up a large amount of space for electronics. So just doing some brainstorming here, and I'd like to mount them right in this location right here. And in the aircraft, there's a ton of room because it's got that whole area. So if we were to mount those fuel pumps, it would go right there, which is perfection because it's nice and close to everything. So one of the common questions I get is, what 3D printer do you recommend? Well, here at the shop, we are 100% bamboo. So we've got 2 Bamboo X1 carbons. I absolutely love these things. They are so easy to use. I haven't used them in a couple weeks, and they just did an update. I came up with a fuel pump mount design in CAD, uploaded it to my printer, and it's printing. Now, the one thing I love about these printers is you can pretty much guarantee that it prints perfectly almost every single time. So it's supposed to be done, these 2 mounts, in about 20 minutes. So we'll come back and check them out when they're finished. So with our fuel pumps mounted back there, that opens up a ton of space here. So basically we're going to have a lead coming from here, or a fuel tubing coming from here, going right like that. There's tons of room in this area. And then the line here goes to our fuel tank, which is mounted right there. So super simple. And what that means is we can basically mount some of this stuff right in that area there. So if we mount our central box like that, we can mount our Cortex right there, and that gives us all of this space here on the tray to mount all of our air stuff, our lighting controllers. So that is perfection. Now I think we might put either our through fitting for the wires right here and here. We'll have to see how that's going to work out. We could put one right there as well too, so maybe I'll put it right up here. Actually, that would work okay. But we got lots of room, so if we put a through fitting right there, that gives us lots of ability to go to here, to go to the gyro that's going to get mounted there. So I'll probably put another one over here for airlines and leads going to the air controller. And this is one of those other devices that I printed a bunch of, and this is a Cortex mount. So the reason I like to use a mount like this instead of sticking this to the board is I know that this is a nice surface that this sticks to and doesn't come off. And then this also becomes removable if you were to ever want to take this Cortex out and not completely destroy the sticky stuff or the double-sided tape. So just stick the tape to the Cortex, and this is pretty stinking accurate fit. So just get it nice and centered side to side, and boom. So no excess. It's exactly the same dimensions as the outside of the Cortex, and of course the screw holes there. So now that can get mounted on the board as well. So with Cortex mounting, I will generally always try to use the default position. So when you first set up a Cortex, what happens is the position by default is always plugs forward, plugs up. So if you were to relearn the radio system to either a different receiver setup or a different radio system, or just do that process again, those things reset. So if you have the Cortex turned around for some reason, so let's say you have to mount it like this, what happens, or you choose to mount it like that, what happens is if you learn the radio system after you've programmed everything again, like not just the stick holds if you're familiar with Cortex, but I'm talking about learning the radio system like the receiver type. This position defaults back to the default position always. So if you have it positioned like this and you've set it up like this and you relearn to a new radio system or new receiver or whatever, it's going to default to this position, which could be very bad if you don't remember to turn it around. So that's why in general, I will always try and put it in its default position, which is like that. So plugs up, plugs forward. And 20 minutes later, our print is complete. So now this is time to check it over and make any modifications that I think we need. So as far as our overall dimensions here, our whole center to center looks perfect. I just kind of guessed on the outside dimensions of the head of the screw. So we'll pull out a 3mm screw and see if it fits. All right, so thread that in there. I mean, it'll fit. I don't really know if the recess matters too much because it's not recessed enough that it's going to hide the screw head. So, but that dimension is actually good. Okay, so one screws in, the other one would fit in there perfectly. So that is kind of how I designed it, because it's supposed to mount right back like this. I left no screw holes in here, so you could either glue it or screw it down, so you just drill a hole. So right now, this is my only concern, this area right here. So this area, I think I did it at 2mm wide, maybe about 2mm. And this is PETG carbon fiber material, so it's fairly strong, but because of the way this is printed, this is our bottom and this is our riser here. So our layers are added on to each other, which means that it's going to be most fragile in that dimension right there. So what I think I'm going to do is make that thicker. Obviously our base where I added the little triangle stock piece is good, but we do need to be thicker on the vertical just to add some more strength to everything. So I'm going to go back, redesign that guy, and otherwise this is perfect. That's what I'm looking for. All right, so we got both of our fuel pumps mounted here. There's the modified support. So that is basically 3 millimeters now, same as the vertical or this portion of it as well. So it's all 3 millimeters, nice and strong, and will be no problem. It's quite flexible, of course, if you really push on it, but the material itself is flexible. So those are done, which is awesome. Next thing we're going to do is kind of work our way through the rest of the items here. So basically I'm going to, I think, get our through fitting done up first here, and then we'll start to mount everything else around that. But it's going to be a pretty straightforward setup. So we've got our central box, Cortex, all of our air stuff, or as much as possible is going to go there. I've been playing with some other things here. This is a different version of the Skymaster controller. I've never seen this one yet. The old one looks almost the same, but the old one was called the NLC, or the other one was called the NLC 751, I think. But so this one's nice. It's got a metal case versus the plastic case. The downside is there's no labels on, you know, how this plugs in. So, you know, I'm not so concerned about this one because I think the center plug was positive and either the top or bottom was negative. It was universal if it's the same as the previous one. But then you've got your plug-in side, which who knows? Now I could make some assumptions and say, well, if I look in there, I see 2 dots or 2 of the squares right in between the plug sets. That could mean that that's power and this is signal, but I don't want to mess around with that, so I've posted on the Skymaster forum on Facebook asking for some help. All right, and fresh back from Joe Nall, where we picked up our pilots for the F-15. So we've got 2 of our Warbird pilots here, and they are moving heads. We've got the randomizer as well too. Now these pilots, I think they are, well, they're the 1/4 to 1.45 scale. So the pilots that we used in the SU were a little bit smaller than those guys, like the next size down, but I think the seats are probably the same size in both aircraft. They look the same. I haven't measured them, but they look very much the same, but I think those pilots should fit in there nicely. The big difference though is, like, if you just look at the perspective of the canopy area here compared to here, it's substantially different. Like the 15's much bigger. So you wouldn't want to use the, well, at least in my opinion, you wouldn't want to use this size pilot in the 15. It would just look too small. Okay, so we got some of our stuff mounted here on the board. We've got our fuel pumps mounted, which is awesome. We did pick up our UATs as well too, but we're missing some of the hardware, so we're just gonna hold those or put those on pause, which isn't a big deal, of course, because we've got them all laid out now. Jetty box is mounted, our fail-safe sequencer is mounted, Cortex is mounted, we've got our through fitting there, which is great. So next thing to do is start planning out the air system. Now the air system is quite versatile with how we have this laid out. So right now, this is the doors that open and close. This is air brake. This is everything else. So the green and the yellow are the doors that stay open when the gear is down. Blue and red are the gear up, down. Black is brakes. So with the amount of line and stuff here, and because we're putting all of our air system stuff right in this area, we've got a lot of freedom as to where to run those lines. So I did touch base with Skymaster. Anton posted on the forum. I'll put a picture up of how this thing gets laid out. But according to the picture, the inputs here, the signal is on the bottom. This side, I don't know if it matters so much, but the picture shows the signal on the top. So your positive, of course, is in the middle, negatives on the bottom. But he's also got this going into some of those expander pieces, these guys, which I don't generally use. But anyways, at least we've got the layout here. The important thing is just remembering that on the input side, the signal is on the bottom. All right, and the other thing that we are missing in the kit is the air cylinder for the canopy actuator. So fortunately, I keep my Skymaster cylinders, which is great because Anton came back and he said a 100 millimeter cylinder, which is pretty much this guy right here. So this is the one that should work. The only thing that we'll have to do is do our extension arm on this guy, because it needs to come up to right there. So that's not a big deal though. We'll figure that out. No problem at all. All right, so in past videos, I have kind of just said, okay, we're gonna do this wiring and just kind of gone boof. But I'm gonna show you guys a little bit more of the steps here that I go through when I do this. So kind of know that all of our air valves are gonna go here, and I was just planning out our outputs. So, or inputs, I guess is the best way to put it. So want to make sure that we have enough of our ports available so we can get everything hooked up. So the way this is going to work is we are going to have R1, of course, going to Cortex. We've got extra power lead going to 5. B is going to be our primary receiver input. Because we're using a clone, our clone is going to go to the primary receiver, and we'll also have another port coming to R2. So the clone, which is going to be an R7, has a port E1 and E2. Both of those ports, one plugs into the central box R2, one plugs into the other port of the primary. Anyways, if you're confused by that, just go with me. R3 E1 is going to be our 900. We've got our switch, of course. E2 is going to an expander. Now we need to use the expander because of all the different devices we have. We've got turbine telemetry 1, turbine telemetry 2, Chicoy sequencer, M-speed sensor, V-speed compressor. So we've got, I don't even think I'm getting everything, but we've got a bunch of things, telemetry devices. So we've got enough ports here with all that stuff going into E4, and then I think probably the compressor going into E3. Doesn't really matter where the compressor goes though. And I think we do have port 18 available as well. So anyways, and then E4 is going to be our SE6 expander module. So this is where a couple of our valves are going to be run off of. So that's kind of the initial layout here. So I was just getting some of our wiring done. So our input for our gear, our Cortex leads, those are done up. We've got our expander put in there. And then what I'm doing now is getting our wiring harness done for the turbine. So with our hub being mounted here and everything else being in the front, the nicest way to do this is to make a wiring harness that goes from here to the central box with an intermediate stop or open wire coming to the fuel pumps, which mount right in this area. So that's the reason for our 4 wires here. So we've got throttle, telemetry, and terminal. Now this terminal lead is just going to go to the front of the fuselage, the front of this portion, and there'll be a plug coming from the front that plugs into it. So it's basically just an extension with a break point at that location, rather than just running one wire all the way forward to the nose and not having a break. So that's the point of the harness. This heavier wire is aviation wire, and this is what I'm using for the fuel pumps. We're basically just going to cover this in snakeskin to this point, and then that's going to be hidden underneath here and run down that support right there. So, but it'll be a nice plug-in system right here with all of our leads just plugging in. They're all going to be marked as well too. Battery port right there. We're going to get that done up eventually here, but that's just going to, again, run this way and run kind of the same path. All right, so situation like this, I like to make sure everything is angled and done properly. So we've done the ends on this one side. The other ends are not installed. When I do these ends, I make sure one of my power box wires has no marks, one has 2 black stripes, one has 1 black stripe, and then I repeat the same thing on this other side. So once you get the snakeskin and everything done, you know what is what on this end. So what I've done here is installed our snakeskin, and we're going to take our shrink tube here, our heat shrink, and we're just going to get this run so all the angles and everything are where we want them to be. So because these wires will move in and out a little bit, I want those wires to come straight back or straight sideways like that. So that means that now when I shrink this tube and everything, the wire is all done in the correct location. And we'll take our mini heat gun and shrink that heat shrink at the right angle. Perfect. So now I can pull this wiring harness off, and all of our wires here, whatever length they're at, are all correct to go into the left hub. Just like that. All right, so first wire harness is all complete. We've got it plugged back in, everything's finished on it. All of our ends are done. So they're all normal ends except our terminal end, because that's gonna have another cable that plugs in here and goes forward. So now we'll do up our other side, our right side, exactly the same way. All right, so I have progressed with our wiring for the turbine. So we've got our wiring harness that we worked on that comes here and goes down. We've got our power wire that we did up. So we took a little section from the stock end, soldered it onto a piece of larger gauge wire, and that runs forward. And then we also have the wing wiring as well too. That comes to this point. And if you look here, you can see all of them go down these little keepers. These little keepers are ones that I printed. The file I think is on Thingiverse. And of course we printed those on our bamboo printer. So those are stuck in place, wire comes down, everything goes underneath the tray. So it's actually gonna be really clean here, not a jumbled mess of stuff. We also got our lines from our main tanks, the saddle tanks installed on the main tank vents, and those are safety wired. So again, these tanks fill up, come out the vent line, go to the saddle tanks, fill up, come out the vent line. Vent lines will be teed off here, and we're gonna go to underneath the fuselage right in this location here. So I want it to be hidden, but also fairly easy to locate. So it's going to be right underneath the intake duct in that location, which is basically on the underside of the plane, is right here. So you'll be able to plug it in and then have your overflow tank sitting on the wing or on the fuselage. So as far as back end stuff goes, wiring is complete to the turbines forward. Reinstalled our air cylinder for the air brake. Did that so we can put some spiral wrap on our air lines. Used a large piece of shrink tubing over top of the air cylinder to keep everything nice and tucked in. And did this instead of the tie wire, or the zip tie as we call them, holding that airline on. So it changes it from silver to black, obviously. So we are still gonna shoe goop these connectors in place, but as far as wiring and tubing and stuff goes, this section is done. So now we're able to get back to our jumble of mess here. This of course is getting way more messy and way more jumbled, which is perfect, because once we get that organized, it all disappears. So I haven't done anything more with the main board here. Wanted to get all that stuff dealt with, and now we can deal with that wiring so we can get the main board installed. All of our wire leads are now installed on, or all of our ends are installed on our wire leads. So we're almost ready to put the tray in, but we've got to figure some other stuff out here first. Primarily our lighting system. So what we're doing here is we've got the Skymaster lighting controller, which is going to control all the scale lights on the plane. And we've got the Castle Creations BEC 10 amp one. This is going to feed the Skymaster controller, and this is dropped to like 4.5 volts, I think. Yes, this says 7.4 volts. You don't want to run 7.4 volts to the LEDs. You want to drop them down, trust me. We've got an SP06 installed in here. The SP06 is going to allow us to turn the controller on and off. We're going to run everything through a BEC, so the Unilight 15 amp BEC. And the point of the BEC is we're taking our, we've got 4 3-cell batteries powering this plane. So we're going to have power coming to our input, which is this guy right here from the 3-cell LiPo. And that's going to drop it to 8.4 volts. So we've got our lead here, which is feeding our Unilight afterburner lights. That's going to get connected to one output on the BEC. The other output is feeding our Skymaster lighting controller. So that's how everything's going to get powered for the light system. Now I'm going to be installing this stuff kind of just down in the base. These things we're going to put underneath the tray here. The BEC, our tray ends right there, so that's going to be sitting right in that area right there, so we do have access to it. But so this will be visible, that stuff will be hidden. All right guys, so we are ready for our plate on this end. So we've got our 2 turbine leads here. These are going all the way to the front, and the turbine leads are uninterrupted. The way I've set this plane up is basically the turbines are uninterrupted, so battery goes to turbine, and our light system is going to be run off battery number 2 on the central box, or paired up with battery number 2, and our compressor is paired up with battery number 1. Now what's the mentality behind that? Well, the turbines need 3-cell LiPo to run, so better to have no voltage drops or anything like that. Now we've done them off the turbine batteries in the past and they're totally fine, but just thinking about this stuff, and the batteries for the turbines, they're going to be at 12.6, 12.4, 12.2 volts basically for the flights. And the receiver portion, because it's going through the central box 310, that gets dropped to 8.4 volts. So even if the batteries were to get a drop to 11.5, 11.6, the central box portion isn't going to know or do anything different because it's already dropping the voltage. So that's my theory behind it. Anyways, that's how we're pairing up the batteries. So basically things are ready to go here. Our BEC, I've included the wires on the central box. Now I'll take you over there and show you that. So all these wires here are going to be looped around and come up through the hole in the plate. We've got one shorter lead here for afterburner lights, so I'll probably have to undo that one and run that straight over and up. But that's how that stuff's organized. We've got all of our lights plugged in except the 2 nose lights, which are our landing gear lights marked right there. We have to use a little splitter for those guys, but all of our other lights are plugged in. And then on our central box here, this is how we have things wired up. So this lead is going to the BEC, the Unilite BEC, and that's tied up with or paired up with battery number 2, comes over, battery number 1 is uninterrupted to this point, and that goes forward. If you look, the lead is a little bit shorter than the other one because that lead is coming over to here, which is where our compressor is in the nose. So there'll be a joint in the wire. This guy will be tied in, and then we'll have the rest of the wire going forward, another foot or so, to the nose cone section. And the next thing to do now in our organizational journey is to get our air valves installed on the plate and get our preliminary air plumbing all sorted out. Now we've got our air lines coming forward, of course, and those are pretty straightforward. We've got our doors here, which are, I've already talked about the doors that open and close. We've got our air brake here, and then our other ones here. So some of those are gonna come, like the gear, for example, some of those are gonna come forward, they're gonna tee off, and they're gonna go to the valve, but then they also have to go forward to the front gear. So those are some of the things I'm thinking about when I'm organizing this stuff out. So I'm going to work on the layout a little bit, and I'll come back and show you guys. Now, one of the things I like to do during this step is program our sequencer. So this is kind of an important one because then it's all done, it's easy, it's finished, and just makes life a lot easier if you do that stuff now. And our board layout is complete here. I think I'm going to mount these 2 guys in the nose. This is the Canopy lock, open, close. Yeah, I think that's where I'm going to mount these. Still undecided, but that's probably where those guys will end up. So we'll leave those aside for now. So we've got air brake, which is going to plug in to right there. There's going to be an extension that goes underneath the board, comes up and plugs into the appropriate port on the central box. Wheel brake, same thing right here. Extension comes underneath, goes into the central box. We've got our gear right here that's not plugged in yet. Doors 1, so that's doors that open and close, and doors 2, those are doors that stay open. So that stuff's done. Next thing to do is our board plumbing. So the only thing that's really a kicker here is our wheel brakes are going to be powered or aired up by the gear down portion, And our canopy system is also going to be powered up by the gear down leg. So on that valve, gear down is the one closest to the base of the valve, which is this guy right here. So when this is pressurized, it's going to tee off and pressurize the brakes. It's also going to tee off and go to the landing gear, and then it's also going to tee off and go to our canopy system. So the only time the canopy is pressured up is when our gear system is in the down position. So we got our EXT or extension ports plugged in. So we've got one EXT coming from the RC switch. This is the on-off switch. Another one from the Cortex. Another one for the Chicoy sequencer. But we've got that pulled out because we have our programming hub installed right now. So this tray, other than our programming, is pretty much 100% ready now. All of our leads for our EXT or extension programming ports are here. Those all go towards the nose of the aircraft, so they're all labeled. And obviously we've paired the RC switch to the radio. So we're ready to turn this thing on. I have already programmed the Cortex. So if we turn this on, everything should work as it's supposed to.
Receiver on.
And there we go. So what I'm doing at this stage is essentially programming the air system is what we're doing. So what we're doing at this point now is we're going to program our gear solenoid. So the primary one, the doors 1 and doors 2. Now these Chicoy valves, they will operate on and off. So if you use this valve, it'll stay on for about 10-15 seconds, and then the valve itself turns off. So right now there's no pressure, or neither side of those solenoids are open. But all you need to do to change that is you push the button, and then now that solenoid is in operation mode all the time. We'll do the same thing on the air brake. Here we go. Wheel brake, that does its thing. So now those are ready to program. All right, it's time for another episode of Tip Time, and this Tip Time is going to be brought to you by Trusty Bent Screwdriver. This is a really good one for programming the Chicoy controllers. This is a big one. All right, so our air system's all programmed. How did we get to this step? Well, first thing I did was get our gear solenoid programmed. This guy right here takes a little bit of finicking on, or it's a little bit finicky on the high flow system, but that one's done. Then what I did is I found out where this Jetronic valve likes to open. Or likes to start up. It likes to start up on the green side. Don't worry about the O and the C. We'll talk about that in a bit. The Chicoy valve here doesn't really matter at this point. So how does the Chicoy sequencer work? Well, this is the way to look at it, and this is the easiest way to decipher what these things do. First of all, this gear controller works in closes and opens. That's the terminology used in the controller. But you don't want to use that terminology when you're thinking about your gear doors. So it could say open, but your gear doors are actually closed. So that's not really important. Think of the open and close as position 1 and position 2. So first thing we need to do is we need to find out where our valves are going to be in the gear down position. So in gear down position, the first solenoid, which is port number 1 on the Chicoy controller, that is in the C position, closed, which doesn't really matter. Now, if you're using more than one gear solenoid, you want to have a Y cable and both of those solenoids going to port number 1 still. That's very important. Doesn't work well otherwise. Door, or we'll call port number 2 main doors. Now, this is marked as open, but those doors are actually closed when the gear is down. Port number 3 is the small doors right by the actual main landing gear. Those are open in the gear down position, but they're actually on the controller. We're using the C position, which is closed. Then what I did was I came through here and blew some air through the line. That's what my compressor hookup here is for, and found out what these valves are actually doing, and then I marked these valves out. So green side on the Jetronic valves, this is our close line for the doors. This side's our open line. The Jetronic valve doesn't really matter. I just left that where it was. This is our gear door open, that's our gear door closed. And then when you're setting this up, you do the steps and you figure out what you want to do. So gear down position, we're working our way towards gear up. So what happens? Step number 1, our gear stays in the same spot. These doors open. It's labeled as a close or a C, but again, that doesn't matter. These doors are already open, so they're going to stay open. Then what happens on the next step is our gear changes and comes up. These doors stay open. Step number 3, we're repeating the exact same thing, but this is where you have a bit extra programming set up where you could change this or do CCC, CCC, and then OCC. And then our gear up position, everything is O. So O is gear up, this is doors closed, this is doors closed. Now when you're dealing with the Chikoi sequencer, when you're going from gear up to gear down on your switch, everything works in the exact opposite. So what will happen first here is the door or the gear stays up, door open, gear stays up, door open, gear comes down, door stays open, gear stays down, these doors close, these doors stay open. So if you just wrap your head around those steps, it does make this whole process easier. Yes, I know it's confusing, but having dealt with these things many, many times, once you wrap your head around those steps and draw the graph out like that, it makes it so much easier. So that is how to program the Chikoi controller, fail-safe, and thank you, Trusty, for your help. All right, guys, and that is going to wrap up video number 6 in the build of the Skymaster F15 XXL. The plate is ready to install. So next video, we are going to install the plate and we're going to start working on our cockpits on the nose section, and that needs to happen before we bolt the nose to the fuselage. But in the next video, we'll be bolting the nose to the fuselage and making the plane look much bigger than it is. So stay tuned for that. Thanks guys for tuning in and supporting the channel. Thank you channel members for what you do. Thank you for supporting the channel member. If you're curious and you're watching this, what is channel membership? There's some links down below to channel membership. It's a paid thing, but channel members get to see our videos early before they're released on YouTube. So thank you channel members for doing that. Thank you guys for supporting the channel, for watching my videos. We'll see you in the next video. I'm very excited to see everybody at Turbines and Tumbleweeds in Sweetwater, Texas, October 2nd to October 5th, 2025. See you there.